Welcome to springlib.
Hello everyone, today we're doing chapter 18, problem 54, and this problem asks us to draw a stepwise mechanism for the following reaction. So what we have here is benzene, and then we have some sort of Friedel-Crafts alkylation reagent to get two products and HCl. So right away we know that this is going to be an electrophilic aromatic substitution reaction, and what we need to do, this is two steps. First, we got to make our electrophile. Second, we got to use the benzene as our nucleophile, using those two electrons in the pi bond to nucleophilically attack our electrophile. So first, we will make the halide, the alkyl halide specifically, into our electrophile by reacting it with our Lewis acid. So chlorine has 3 lone pair electrons, and chlorine will use one of those lone pair electrons to nucleophilically attack our Lewis acid. And now what you have, the chlorine lost 2 electrons, so it's going to have a positive charge. Aluminum gained 2 electrons, so it's going to have a negative charge. And what you have here is now some sort of intermediate structure in which chlorine has a positive charge, but that's not very happy, and aluminum has a negative charge, and it's not very happy about that. So what's going to happen is that chlorine will pick up 2 electrons from the sigma bond to now form your carbocation electrophile, which is now a primary carbocation, plus your conjugate base, AlCl4, minus, and now we have this primary carbocation that our nucleophile can react with. But what we know about primary carbocations, well, they're not that stable. It would much rather be a tertiary carbocation. So what can happen is that we can have some sort of resonance form being occurring, such that this pi bond moves over here, and we get another electrophilic intermediate that's now a tertiary carbocation and far more stable. So now this is complete step 1. So step 1, we created our electrophile, which is a primary and tertiary carbocation. Now step 2 is reacting that with our nucleophilic benzene ring. So what we're going to do is first let's react it with the primary carbocation. So using the 2 electrons on one of the pi bonds in the benzene ring, we'll go through a carbon atom and hit this carbocation to neutralize it. Remember to always count your carbons. 1, 2, 3, 1, 2, 3. And we have a carbocation intermediate here. So now what's going to happen is that obviously this is going to be resonance stabilized, such that the pi bonds will move around this carbocation throughout the ring, but eventually the conjugate base of our Lewis acid is going to want to reform itself, and we know it's going to reform itself. Why? Because this is an acid catalyzed reaction. When you hear the word catalyst, well, catalysts are always reformed at the end of the reaction. So we need to reform this aluminum trichloride at the end of the reaction, and the way we can do that is, well, we can use these 2 electrons in the sigma bond, pick up this proton to make that HCl, making a bond. When you make a bond, you break a bond. So this sigma bond will now go in and reform the pi bond to regain aromaticity in your benzene ring. Now you reformed your aromaticity in your benzene ring, and you formed your HCl, and one of the products being this one. But now we need to reform the second product. That's the second, using the second electrophile. So once again, we'll start from benzene. And using the pi bond electrons, we'll go through a carbon atom, hitting this carbocation. Forming a carbocation intermediate in which the conjugate base will neutralize by picking up this alpha proton and reforming aromaticity in our ring. And now we formed the second product. Plus HCl.